All right, we can get started. All right, let's take a look at this problem. So you submitted this one, so I'm not going to start the timer for this one. Um, all right, so I think one way to do this one is to just pick an easy value for P. Uh, so I'm just going to make P equal to 1. All right, I think that's probably the easiest way to do this. And if P is equal to 1, if I want the length of the radius, then it says the length of the radius is n times P. So if I'm choosing P to be 1, then the length of the radius is just n. All right, so basically, as we attack this problem, I'm just trying to find the radius of this. You could use Desmos, but I am going to go over the way to do it without Desmos to kind of review the standard form of a circle. And let's just refresh what that is. So the standard form of a circle looks like this. So we're just in search of R. All right. So first thing I'm going to do is divide everything by 8. So I get x squared, 112 divided by 8 is 14. Remember, P is 1, so it's 14x, plus y squared. Again, P is 1, so minus 8y equals, and then I need negative 448 divided by 8. That gives me negative 56. So then what I need to do is find what I need to add to each of these to complete the square. So we have x squared plus 14x. The way we complete the square is we take half of 14 is 7, square it. So I'm adding 49. And then on the other one, y squared minus 8y. Well, half of 8 is 4. 4 squared is 16. And then on the other side, I've got to make sure that I add both of those numbers. If whatever I do to one side, I do to the other. So I add 49 and I add 16. And the reality is, if I want to know the radius, I really only care about this right side. So I'm just doing negative 56 plus 49 plus 16, and that gives me 9. All right. So the answer to the question is the radius. Well, 9 is r squared. So if 9 is r squared, then that means the radius itself would be 3. And again, we chose P to be 1, which means the radius of the circle is n. And if n is the radius, then the answer to the question is 3. But just to finish going over, that's how I would just the real. I'll show you two things. So just to make sure we understand all the concepts, this would become x plus 7 squared, and this would become y minus 4 squared. So then we would know that the center was negative 7, 4, which again, this problem does not ask. So, but I just want to go over that because some problems might ask that. So first off, any questions on that, how I got the answer 3?
No, that makes sense.
Okay. So then, like, an even faster way to do it would be to kind of get to the level where you don't even like do all this down here. You simply just know that you complete the square twice. You just know this is going to lead to 49 and this is going to lead to 16. Just add them to this side to get 9, and then you know the radius is 3. So there are ways, like once you understand the concepts, to do this even quicker than you would in Desmos. But Desmos would work too. But you are, no matter what, I think, gonna have to pick a value for P. I feel like to try to do it like with P in there, completing the square and all, is just like a lot of work. Or throw it in the Desmos and then like use a slider, and but you're still gonna have to choose a value for P.
All right.
Okay. All right, let's move on to number two. I could make this a little bigger. Also, this one I will just start the timer. I'll give you just a little bit of time to try this problem for those that didn't submit this. Okay. So this is another one that if you wanted to, you could choose a value for D, and then kind of throw it in the Desmos and add 9 and like find the x-intercept of that. But I actually found it easy enough to not have to do that. So two things that you want to do right away is this whole thing is f of x, and they're asking me a question about that plus 9. So I would just like immediately add 9 to this. So I get 6d times 20x plus 21 plus, well, 17 plus 9 is 26. All right, so I would just do that right away because that's pretty straightforward. And then if any question really ever in math asks for an x-intercept, you're just making the y 0, right? An x-intercept is when y is equal to 0. So this is just what we're trying to do. And then we're trying to get x by itself. And again, that's why D is in all the answers. So if it's easier for you to pick a value for D, the problem with that though is you then got to plug it into all the answers to like get whatever numerical answer you get, which I like doing sometimes, but I think in this one it's not really faster. So just to get X by itself, I'm just going to distribute. So 120 dx plus, or yeah, plus 126 d plus 126. All right, so that's just what I get after I distribute. And then I'm just trying to get x by itself. So I'm going to move these two terms to the left side. So negative 126d minus 120, sorry, minus 26. For some reason, I wrote a 1 here, but that is wrong. So I'll go fix that in a second. All right, so this over here was supposed to just be 26. Okay. And then I would probably stop there because the way that I'm going to get x by itself is I'm going to divide each side by 120d. And I can see that the only answer that fits that is A. So that's also why I would choose to do that, not by picking a value for D, because I feel like the algebra is simple enough, and you just got to get to a point where you know which answer like actually makes sense.
All right, got it.
Yeah, so like I said, yeah, I'm trying to think. I mean, maybe if anybody wants to do it that way, try it. But like, yeah, like I would probably just make D1. But the problem would be that you would find that the x-intercept is whatever negative 126 minus 26 over 120 is. I don't know. Like it's just not going to be, you're going to have to plug it into all the answers. So I feel like it's just to know the concepts here is the fact that obviously add 9 to the function and then x-intercept makes just y 0. Okay. Any questions before we move on?
Nope.
Okay. All right. So again, this one, I'll give you some time. This one was pretty challenging. Make it a little bigger. Okay. All right. This one I thought was definitely the hardest one that was submitted. I definitely got the answer, but there could be quicker ways. So the first thing I noticed was um, when we know it's a parabola and we have two values that are equal to each other, we immediately have to realize that like it doesn't really matter what the y values are. The vertex has to be halfway between those x values because the fact that a parabola is symmetrical. So this tells me that if I just and the number that's in the middle of two other numbers is just the average. So if I just find the average of these, so that's just -6/2, that's -3. That tells me that this h is -3. It tells me that the x coordinate of the vertex is -3. And also, another thing I should know is that if something's in standard form, the x coordinate of the vertex is always -b/2a. So I just put those two concepts together to say that, all right, I know the x coordinate's -3 because it's halfway in between. I know that this is the formula for the x coordinate of the vertex in standard form. So then -b is -4, a is a. So then I just quickly solve this. I get -6a equals -4. So a is 2/3. So if a is 2/3, it cannot be greater than or equal to 1 because it's definitely 2/3. So that answer doesn't make sense. So it's not B or C. So it's either only one or it's neither. So we have to figure that part out. That was the part that I thought was difficult, but all I did was just now that we know what A is, I did the rest in Desmos. So I put 2/3 x squared plus 4x plus c, and you'll see what happens. But before I go to Desmos, I want us to notice the other part of the problem that they told us. They said k was less than 0, which means that that's the y coordinate of the vertex. We need to make sure that's less than 0. So let's remember that when I hop over to Desmos here. So in Desmos, I'm just going to put the 2/3 x squared plus 4x plus c, and I'm going to add the slider. And it actually gives me the answer right away because all I need for the problem to work is I need the y coordinate of the vertex to be negative. So the default slider here has that. And notice that the C, and this is another concept that we have to know, the C value is the y-intercept. So that means that I have a positive y-intercept. That's enough to answer the question because just think this example gave me a positive y-intercept. So again, when I jump back to the actual question, it says what must be true. Well, I just gave an example of where you can get a positive y-intercept. So that means c less than 0 doesn't have to be true. We could probably come up with ways for c to be less than 0, but for that to must be true, that doesn't have to be true. So A is just wrong and C doesn't like have to be true. We found an example that showed that we got a positive y-intercept. So there's like a lot of concepts in this problem that we have to know that this is the formula for the vertex in standard form, the x coordinate, that if we have two values that are equal to each other, the vertex is halfway between them. And this value C on a graph always just represents the y-intercept. So that's why I thought this was a hard problem. I'm sure there's other ways to go about it, but that's again just kind of how I saw it. So does anybody have questions on that?
Got it makes a lot more sense now.
Good. Yeah, I think I would need more time to think about why, like how we could do that, I guess, without Desmos, but it's pretty easy to just at the very end there throw it into Desmos. Okay. All right, so that was everything that was submitted. So I'm gonna jump ahead. So I had a couple other kind of topics just set. Um, so I want to do like tonight, I was just gonna do a couple special right triangles and then actually some circle problems, which is related to one of the questions that we had earlier. Um, so let's keep going with that. So let's take a look at this number 5. And again, I'll give you a minute and a half to try that. Okay, so we have an isosceles right triangle. Hopefully we know that that means that it's a 45, 45, 90. and the hypotenuse is 58. And also on the reference sheet, they're going to tell you that the sides or the sides of a special right triangle, 40 45, 90, is x root 2. So really simply, we just need to set these equal to each other. So 58 is x root 2. I want to figure out what x is, so divide each side by root 2. And then you can rationalize. So I'm going to multiply the top and bottom by root 2. So I get 58 root 2 over 2. And when I divide those, finally, I get 29 root 2. So that means I have 58 is the hypotenuse and 29 root 2 is each of the legs. And in the end, it's asking for the perimeter. So 29 root 2 plus 29 root 2 plus 58 is 58 plus 58 root 2. So 29 and 29 make 58. So we just have to know that an isosceles right triangle is really just telling you that it's a 45, 45, 90. So any questions on that?
All right, makes sense.
Good. Okay, let's keep going with a couple more challenging special right triangle problems. All right, so again, try this one. All right, so we have an equilateral triangle. So one thing we have to realize is anytime you have an equilateral triangle, you're going to be dealing with 30, 60, 90s. Because when you drop the altitude or the height down, right, it's going to be a right angle. And they tell you the height is 24, so we know that. But we also know that the angles of an equilateral triangle, since they all add up to 180 and they're all the same, 180 divided by 3 is 60. So we know this is 60, which is 60 and 90, so this one up here is 30. So then when you look at the reference sheet, the short side is always x, the short leg. The long leg is x root 3, and the hypotenuse is 2x. All right, so that's just what the reference sheet gives us. So now we set these equal to each other. So we know 24 really represents x root 3, and we solve just like we did on the last problem. So you can divide each side by root 3. And then I would like to rationalize. So root 3 over root 3. So we get 24 root 3 over 3. And finally, we're at 8 root 3. But 8 root 3 represents x. So you could figure this out a couple different ways. You could just say, all right, well, if I know x is 8 root 3, then 2x is going to be 16 root 3. And then that's one of the side lengths. So the perimeter is going to be 3 of those, which is 48 root 3. And then they're saying that's expressed as x root 3. So they really just want to know the number that's in front of the square root. So, like, the answer to the question is 48. Or you just realize in the beginning that whatever length this is, 6 of those is going to make up the whole perimeter, and 6 times 8 is 48. So, again, however you want to get it from there. But the thing you have to realize is anytime you ever see an equilateral triangle in the SAT, it's going to be a 30, 60, 90 type of problem.
All right, got it.
Okay. All right. Let's keep going. Yeah. So here we go. We have another one, another 30, 60, oh, sorry, another equilateral triangle. But this one is inscribed in a circle. All right. So, whoops. So try that one. I got to start this. Okay. So we have a circle and an equilateral triangle is inscribed in the circle. So something like this. And we'll say this is the center of the circle. And we're looking for the radius. So I guess we could say like that is the radius. And the side length is of the triangle is 22 root 3. So I'm going to actually put it on this side. So the side is 22 root 3. All the sides are, right? It's equilateral. Um, so I think what we can do is just this. Let's make I could have done it anywhere. Yeah. Actually, let me do this same exact thing but in another place, which might make more sense. Just so we can look at it that way. Okay. So I want to make this little triangle. So we're in search of this, the hypotenuse of this triangle. So again, we are going to have a 30, 60, 90, but now the 30 is going to be down here and the 60 will be up here. Um, because the equilateral triangle, all the angles are 60, and so this part's going to be 30. And if you're not convinced that this is like bisected, another way to look at this is imagine if we had these. So I know they don't look it, I didn't draw it very well, but this is equilateral. So all six of these triangles are exactly the same. And these angles here, like the top of all the triangles, they have to add up to 360 because they form a circle. And 360 divided by 6 is 60. All right. So again, just a quick, like, if anybody's like questioning why we know this is a 30, 60, 90. But again, when you have an equilateral triangle, it's like no matter what triangles you make with it, you're going to have a bunch of 30, 60, 90s. But it is important to know that this one's the 30 and this one's the 60. And then that's why I put it over here. The whole length is 22 root 3, which means that this part of it is 11 root 3. And that represents the 60 side, which is x root 3. So I think it's easy to see x root 3, if that's 11 root 3, then this part's 11. And if that part's 11, then this part's double that, which is 22, and that's the radius. So the radius of the circle is going to be 22. Okay. Any questions on that one?
No, no questions.
Good.
Yeah, understood.
Okay. All right. And we're going to do one more of these and then we'll move on to a different type of problem. So one more um, equilateral. This one has to do with the area of the whole equilateral. Okay. So this one, they give us the area of an equilateral triangle. I'll show you how a lot of times I see students get started with this. So they're just like the area of a triangle is 1/2 base times height, and then they set that equal to root 3, and then they kind of get stuck because the base and the height are both unknown. So it seems like there's not enough information. So what you want to do is, again, we've talked about this on two other problems. Again, I didn't draw this very well, but the if you drop an altitude down, this is going to be a 30, 60, 90. So just label it exactly as you would see it on the reference sheet. And I don't know why I wrote it like that. It's I guess because of that last problem, but it's really this is 60 and this is 30. And that is super important because the side opposite the 30 is the x, the side opposite the 60 is the x root 3, and the hypotenuse is 2x. Right? So if we imagine that, if you want to find the area of this triangle, well, half the base is x, right? So the base is this full thing, but x is really half the base. And the height is x root 3. So the area of, based off how I labeled it, which is exactly how you would see the 3069 on the reference sheet, is just x squared root 3. But the root 3's cancel. So x squared is just 1, which means x is 1. So if x is 1, then the side length of the equilateral triangle is 2, which means the perimeter is then 6, because it's 3 times 2. So like the answer to the problem is 6. But it just, to me, if they give you the area of an equilateral triangle, it's easiest to set it up like this, where this is x and then x root 3. And then the area is just going to be x squared root 3, because again, this x already is half the base. All right, so any questions on that one? Okay. All right, so the other topic I wanted to go over was the standard form of a circle. So we had a question submitted earlier. So I want to go over a couple of others related to that. All right, so I'll give you time to try this one. Okay, so again, like the first problem we did, let's just refresh real quick. This is the standard form of a circle. And let's be clear, this K and this K are different. All right. So this is just the standard form. And the key is the R squared over here represents the radius squared. So if this is to have a radius of 7, then that means the number that ends up over here has to be 49. Okay, so let's just remember that. We want to end up with 49 over there. So then what I would do is, in order to do this, we have to complete the square. You don't want to complete the square with a negative in front of these, so I'm going to just get rid of all the negatives. So the first thing I would do is just make sure that it's x squared minus 6x plus y squared plus 4y plus k equals 0. So just knock that out right away. Then what I'm going to do is three things at once. I'm going to do x squared minus 6x. I'm going to add 9 to that because half of 6 is 3 and 3 squared is 9. So I'm just completing the square. Then y squared plus 4y. And then I'm going to add 4 to that because half of 4 is 2. 2 squared is 4. Then I'm going to bring the k over here. So that's negative k. And what I need to do is make sure that I also, since I added 9 and 4 to this side, that's like I added 13 to that side. So I should add 13 to this side. So now I can kind of stop with this side. Again, we could keep going and talk about what the center is, but we don't need that for this problem. We need this part to end up being 49 so that there is a radius of 7. So we just set them equal to each other. And then you just get negative k equals 36, which means positive k would have to equal negative 36. So the answer is A. All right, so it's a little bit of a harder problem related to um, the standard form of a circle. And also, I don't really see a good path to use Desmos. So even though you can use that on a lot of these, they can definitely ask it in a way where you definitely need to understand the whole completing the square and this side being the radius squared. All right. Any questions on that one?
No questions.
Good. All right.
Yeah,
Just
good.
good. All right. Just a few more here. Okay. I don't think this one is like that difficult, except I want to go over it because I feel like the better you know the standard form of a circle, so again, I'm going to write it out here, the quicker you can do this, and avoid having to use Desmos. This is a really easy one to use Desmos. The only reason I don't love it is because you have to like type in every answer. Well, until you get the right one. Um, So they basically wanted to intersect the y-axis at exactly 1 point, which just means the y-axis, it's tangent to the y-axis. But I'm just going to explain a concept real quick. And if you understand this concept, we can pretty much get the answer just like super quickly by looking at it. So let's remember that the H and the K represent the center of the circle. Oh, I don't know why I know I wrote 16, because all these have 16, but that's not what I want to put over there. Um, I want this to be the radius squared, like the actual formula. And then R is the radius. So I want you to just think about, imagine if you have a circle that is tangent to the y-axis. So I don't know, just something that looks like this. That would mean that the center would be here, and the a radius that I could draw would be here. So the radius would have to equal the x coordinate of the center. And the opposite of that would be true too. If it was tangent to the x-axis, the radius would equal the y coordinate of the center. So we're literally just looking at it like if you understand that, then you just all of these have a radius of 4, and only this one has an x coordinate of 4. Now, it could also be -4, but they obviously don't have that as an option. I could have drawn that over here. But as long as the radius is equal to either plus or minus the x coordinate of the center, then you will have something that's tangent. Again, if that's confusing, it's not like it takes that long to use Desmos. You just try your answers and you'll finally see that C works. Um, but if you understand that, you could do this problem in just like a couple seconds. All right. So again, the general concept is if it's supposed to be tangent to the y-axis, you want the radius to equal the x coordinate or the negative x coordinate. And if it's tangent to the x-axis, the radius would equal the y coordinate, or again, it could be the negative of that. So you just determine the radius first, and then just there's only going to be one answer that'll match that. And B would be tangent to the x-axis, because that's like the opposite of what I was explaining. Okay. Any questions on that?
No
Oh,
question.
no.
Cool. All right. Let me just see. I think I had 8. Yeah, 9, 10. Okay. So I have two more that I had planned to do related to circles like this. All right. So try this one. Okay. So I want to go over this one. Well, I'm going to do this one in Desmos for two reasons. Number one, because I actually think it is quicker because I don't want to complete the square with odd numbers. I know we can use a calculator and just use decimals, um, but I still just would rather type it into Desmos. And I also want to just make sure I go over uh, how Desmos isn't going to just give you the radius, but we can find it pretty easily. So if they want the area expressed as k pi, let's remember the area of a circle is pi r squared. So just notice that r squared is k. So we're just going to go to Desmos, find the radius, and square it, and then that's the answer. So let me jump over to Desmos and just show you real quick why Desmos can be super simple for these circle problems, because all we have to do is type it in just as is. We don't have to do any rearranging. And then it should allow you, it automatically highlights the lowest and highest point. So the distance between them, so to go from -0.5 to 5.5 is a distance of 6. That's going to be the diameter. So if the diameter is 6, the radius is just 3. So that quickly, you could just type it in and get it. So therefore, if the radius is 3, then the area would be 9 pi. So then K would just be 9. All right, so there are definitely problems where you don't have to complete the square if you don't want to. Um, so for me personally, if I see odd numbers here, I would just rather use Desmos. But if they were even, I probably could figure it out more quickly doing it kind of not using Desmos. All right. Any questions?
Nope, I understood.
Cool. All right. Then we're going to do one more problem and then we'll be done. So give you a minute and a half for this one. Okay. So here is an example of one where you're not going to be able to use Desmos. So you're not going to make three sliders and be able to like move it around to get a center of 9, -12 and radius 1. I don't know. Maybe you can, but seems like it'd be easier to just know the standard form and then kind of work backwards from there. So we have x minus h, so x minus 9 squared, and then we have y minus -12, so y plus 12 equals 1 squared, so equals 1. And then we just want to make it look like this. So it's just a lot of expanding, all right? But if we could take some shortcuts, it'll be helpful. So if we can know that when I expand this, that's just x squared minus 18x plus 81. And then this one is y squared plus 24y plus 144. And then what I'm going to do is if I want the thing equal to 0, I'm just going to take this 1 away. And then I'm going to stop there. And I'm going to use the calculator the rest of the time. Again, in an effort to do it as quickly as possible. So if they want A plus B plus C, I don't necessarily have to find A individually, B individually, and then C. What I can realize is that that's just the sum of all the coefficients of X, all the coefficients of Y, and all the constants in the problem. So basically, like everything except for the X squared and Y squared. So what I could do is just run through these. I'm going to have -18 plus 81 plus 24 plus 144 minus 1. And altogether, that gives me 230. So that is the answer. Again, if you keep going, like combining like terms, you'll combine the 81 with the 144 with the -1. That'll be your C. And then your A will be -18 and your B will be 24. You'll still get 230. I just thought it was easier just to expand it like that and then just add everything together right in one shot. Again, to try to do it as quickly as possible. All right. Any questions on that?
No, I understood it.
Yeah, same.
Cool. All right. Well, then we'll make that the last one. So thanks for coming. Again, for next week, if you have any problems you come across, just send me emails and I'll make them part of this.
All right, got it. Will do.
Cool. All right.
Thank you.
Enjoy your week. I'll see you next week.
All right, thank you. See you next week.